So we've got that. It's got a lot of attributes on here from the particle sim that we should get rid of for cleanliness because they might interfere. I do want to keep some of them. I want to keep, for example, so let's just delete everything. But I want to keep around stuff that makes sense for us to use later. So I want to know the p scale later. We're going to want to keep the velocity right now. And if there is even a W, which I don't think there is, but if there was for some reason, I just like, these are the three that I always like to keep around if they exist. So now we got a lot less stuff going on here. We won't have to worry about like mass or drag or forces or anything that you might happen to add to the particle sim, but you don't want here. You know, like that. Great. So we got all that. And then finally, what's the last thing we got to do? Oh, we need to actually set up a whole bunch of simulation parameters. Once again, Point Wrangler. We're just going to set a whole bunch of strings. We'll say sim settings. There's a whole bunch of strings and other values that Bullet will recognize as a point attribute on these packed pieces. So one of the main things that we're going to need to watch out for is, see how a lot of these pieces are right on top of each other? You can literally see them intersecting with the camera clipping plane like this. You know, they're going to explode so fast that that's fine. There's no way that you'd ever be able to see that with motion blur, with, you know, any number of things. But that said, even though we won't see it, Bullet will have a problem with that. So what we need to do is say, Bullet, don't have a problem with that. In fact, don't have them hit each other at all. Let's make up something called a collision group. This attribute is recognized by Bullet. And we'll call it just born, because that's what we've been using in our particle stuff. So the collision group, so everything right now is in a thing called collision group just born. Now there's another attribute called collision ignore. And that says ignore anything in this group. And you probably guessed it, make it the same thing. Now nothing will collide with anything else. Now that doesn't include any ground planes that we have. It'll still collide with that because they're not passing through this Wrangler to get this attribute, these attributes. Later on, after the first couple of frames, we'll turn this off. But for now, before we go into the sim, for these are the pieces that get sourced into the sim, they need to know don't collide with each other. And in order for me to turn it off later, let's determine, and this is not an attribute that Bullet recognizes, but we'll just refer to this in a SOP solver. Let's just store the frame that it's being born on, which is, you know, this frame right now. We'll compare that later to the current frame in order to turn off this collision ignoring stuff. Let's also give it a unique name in case it doesn't have one already. I tend not to, I don't want to be too careful about this because this will screw up any kind of constraints and a whole bunch of other stuff. So make sure that you do this. So we'll just call it debris and we'll make the piece unique to the current frame that it's being born on. So F will be actually in the name, but remember %D will be replaced by something else, which will just be the frame number. And then we'll also have another one of these %Ds, which is going to be the current point number. So that's the name template, essentially. Replace the first %D with the current frame number, the second %D with the current point number, and that's fine. So now when you look at the geometry spreadsheet, I'm going to move this over like that. You can see debris. It has the F depending on the current frame we're on, and then simply copying the number of the current point. That way we can be sure that every piece has a unique name no matter what happened up here when we were creating them. Good. So we got that, we got that, we got that. What else do we got to do? We might need to know the original location of this later on in case we need to do some kind of shading thing. So just say the original position. This is kind of like the rest that we did before, but rest is more of a per point thing, and this is going to be for the location of the piece overall. Just in case we need that, and we're definitely going to want to distinguish this from inactive objects, which we will actually add in later, things to collide against. This stuff that we're adding in, though, is definitely active. So this is make sure that we have that codified here. An integer attribute, active is 1. Okay, so we won't obviously see anything happen over there. Last thing we want to do is, and we could have done it in that Wrangler, but I still like to use the randomize for lots of stuff. Let's give it, they have velocities already, but they don't have a spin to spin around, like an axis to spin. So let's just do a pretty basic thing. It's a vector, x, y, and z. It's how much the spin is around each axis. So I'm just going to say, let's do negative 40 and then 40 for each. So that'll be, random things around each axis per piece. That's stored in W. It's the complement to V for velocity. And finally, that's it. Attribute randomize W. Put a null down to say this is the source. And then let's finally get into making our sim. Our sim is going to be super simple, actually, because we spent so much time setting it up.